Hello Year 7, today we're working through question 16 of exercise 4b of the textbook, which is about the LCM or lowest common multiple of large groups of numbers. So the question has four parts, A, B, C and D. Part A wants us to find the LCM of the single digit numbers 1 through to 9. Part B wants us to find the LCM of the first 10 natural numbers 1 through to 10. Part C wants us to compare the answers to Part A and B to see what do we notice and explain. And then Part D wants us to find the LCM of the first 11 natural numbers. So given we're finding the lowest common multiple of more than just a pair of numbers, we're going to need to use the technique we learned about prime factorization and how that can help us with this problem. Given for part A, we need to get the prime factorizations for everything up to 9. For part B, we'll have to do it for everything up to 10. And for part D, for everything up to 11. It makes sense just to, as a preliminary step, get all the factorizations for everything from 1 through to 11. And then we'll have all the ingredients we need. So if I just write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And we'll just work through these numbers one at a time and work out their prime factorizations. All of these numbers are fairly small, so we won't need to use things like factor trees or even our calculator. It should be quite easy to see how each of these numbers breaks up into its multiplication of primes. So for the first number 1, that's easy enough. 1 is not prime because a prime number requires two factors, 1 and the number itself. 1 only has one factor, so 1 is not prime. 2, the prime factorization is 2 because 2 is already prime. Same with 3, it would be 3. 4 is 2 times 2 equals 4. 5 is already prime. 6 would be 2 times 3. 7 is already prime. 8 would be 2 times 2 is 4 times 2 again is 8. 9 would be 3 times 3. 10 would be 2 times 5. And then 11 is already prime. So now we've got all the ingredients we need, so we can start with part A, which wants us to find the lowest common multiple of the numbers 1 through to 9. So the way we can work that out is we go through each of these prime factorizations, we circle a number the first time it occurs, and then we cross out the first occurrence of that same number in any of the other prime factorizations, and then we multiply all the circled numbers. So here, for the number 2, that's the first time 2 appears in one of the factorizations. It appears again for the first time in 4, so we'll cross out the first 2 that happens in 4. It appears in 6, and it appears in 8. It also appears in 10, but for part A we're only going up to 9, so that's where we can stop. Then we've got 3 appearing for the first time, and it appears again in the factorization of 6, so we'll cross that out, and also in 9, so we'll cross out the first 3 occurring in 9. Then for the number 4, we've got our second 2 that appears, so we'll circle that. It's the first time 2 appears for the second time, and that also happens in 8, so we'll cross out the second 2 in 8. Then we've got 5 appearing for the first time, and that doesn't appear in any of the other numbers from 1 up to 9. Then we've got 7 appearing for the first time, and then in the factorization of 8 we've got 2 for the third time, which is the only time that happens, and then in 9 we've got 3 occurring for the second time. So there's all of our numbers. So what we'll do is we'll multiply all those circled numbers together. So the LCM of 1 to 9 would be 2. And how many times does that occur? 1, 2, 3 times. So it will be 2 to the power of 3 times 3 to the power of 1, 2 times 5, which only appears once, times 7, which also only appears once. So when we put that into our calculator, let's see what we get. So we'll have 2 to the power of 3 times 3 to the power of 2 times 5 times 7, and that is equal to 2,520. So that means the lowest common multiple of the single digit numbers 1 through to 9 is 2,520. Panic boom! Alright, now part B wants us to find the lowest common multiple of 1 through to 10. And we will just follow the same process, but notice that when we get to 10, so we've already circled all the numbers that arise from 1 through to 9. We did that for part A. And if we were doing 1 through to 10, then once we had circled the first 2, we would have crossed off this 2 in the factorization of 10. And once we circled the first 5, we would have crossed off the 5 in the prime factorization of 10. So actually, given there's no new prime numbers arising when we add this 10th number, the prime factorization would end up the same. It would also be 2,520. Panic boom! And that leads us to part C, which wants us to compare our answers to part A and B, because the answers are the same. And it's easy enough to see why in terms of the mechanics of our prime factorization technique. But in terms of explaining that, the reason why is because the factorization that we just worked out for part A, being 2,520, that factorization, when we add the 10th number, because 2,520 is divisible by 10, well, what that means is when we try to add 10 as another number, it won't add any new multiples because our lowest common multiple is already divisible by that number. It's divisible by 10, so bringing 10 into the mix won't add any new multiples. So hopefully that makes sense as to why you would end up with the same LCM, whether you're doing numbers 1 to 9 or 1 to 10. And hopefully the mechanics of the technique make that really clear. There's nothing new getting added here. Which leads us to part D, which wants us to find the LCM of the numbers 1 to 11. And again, looking at the technique that we use around prime factorization, the numbers 1 through to 10 have already been dealt with, and there's only one new prime factor with the 11th number, 11, which hasn't occurred before. So really when we work through the multiplication, we would get the 2,520 that we've already worked out, and we'd simply be multiplying that by 11. So if we were going to do 1 to 11 from scratch, if we hadn't already worked out A and B, we would have had to get the 2 cubed times 3 squared times 5 times 7, and then multiply that by 11. But here we've already worked out that that first component gets us 2,520. So now we just take that and multiply that by 11. So if we come to our calculator, say take that answer and multiply by 11, we get the number 27,720. So 27,720 would be the lowest common multiple of all the numbers 1 through to 11. And that's it for question 16. So hopefully you found that explanation helpful and it's all made sense to you. And tick boom.